There are many warm currents in the world's oceans, and in this regard, the Gulf Stream is not unique. However, what sets it apart from other similar oceanic flows is its size. Imagine a massive warm river in the ocean, 70 to 90 kilometers wide and up to 1.5 kilometers deep. The Gulf Stream affects not only Europe and North America, but also the climate of the entire planet. And it's not just because of its size. The configuration of this current is also unique. It originates near the equator in the Florida Strait, then flows along the eastern coast of the United States. After that, it detaches from the coastline and moves northeast. This is another feature that distinguishes the Gulf Stream from other warm currents. After separating from the American coast, it doesn't turn back toward the subtropics. Instead, part of it moves north into higher latitudes, where it transitions into the North Atlantic Current and branches out. This unusual turn has a reason. The very salty, and therefore denser, tropical waters carried northward by the Gulf Stream begin to cool and sink to the ocean floor. This process, in turn, gives rise to cold currents like the Aso. This is how the Atlantic Meridional Overturning Circulation, AMOC, works. It is a complex system of currents, sometimes referred to as the climate engine. For centuries, it functioned like clockwork, but now scientists are warning that its key component, the Gulf Stream, is slowing down, and with it, the entire AMOC is weakening. Estimates suggest that by the early 21st century, the strength of the current system had decreased by 5 to 10% compared to the 19th century, and the outlook is even more concerning. What is causing the AMOC to slow down? The waters of the three northern Atlantic seas, the Greenland Sea, the Labrador Sea, and the Erminger Sea, where branches of the Gulf Stream reach, have warmed. These seas are sites of deep water convection, meaning that in autumn and winter, warm water from the Gulf Stream cools and sinks as deep as 2,000 meters. This cold water becomes part of the deep North Atlantic Current, which flows southward, crosses the equator, and merges with the Antarctic Circumpolar Current. If global warming continues unchecked, the strength of the AMOC in the Gulf Stream could decline by 20 to 30% by the end of the century, potentially triggering severe climate consequences. Temperatures in Europe could drop, bringing harsh Russian-style winters. The eastern coast of North America would also experience significant cooling, along with rising sea levels. However, we shouldn't expect superstorms flooding New York or sudden flash freezes. And the climate crisis wouldn't be limited to Europe and America. If the AMOC collapses, India, South America, and West Africa could suffer extreme droughts and desertification, putting billions of people at risk. Some cities in Russia would also face harsh new realities. Still, these problems might seem like minor inconveniences compared to the catastrophic scenarios that could follow. One such scenario could unfold near Greenland, around the island of Newfoundland. For 1,000 years, this system remained stable, but due to global warming, Greenland's temperatures have risen. This region is unique. 3/4 of the island is covered by an ice sheet with an average thickness of 1.5 kilometers. The ice constantly moves and changes, flowing toward the coast at about 150 meters per year, where it breaks off to form icebergs. Currently, the melting rate has reached 500 billion tons per year. This massive influx of fresh water may eventually make the Labrador Current significantly less salty. If that happens, the Gulf Stream will stop reaching high latitudes and become a loop confined to the tropics. Europe will no longer be warmed by it, and the climate consequences could be devastating. Our planet constantly swings between heat and cold. Over the past 2.5 million years, Earth has gone through at least 50 ice ages. Some scientists believe these temperature swings could have been triggered by changes in the Gulf Stream. more precisely by the complete shutdown of one of its major branches, the North Atlantic Current. 12,000 years ago, Northern Europe was covered by a massive glacier, and the Baltic Sea was just a lake of meltwater unconnected to the global ocean. This scenario could repeat in our time if the North Atlantic Current halts again. In the past, glaciers extended as far south as the 50th parallel, roughly the latitude of cities like Kharkiv, Prague, and Krakow. So all of Europe would be affected. Northern Poland and Germany, the Benelux countries, and much of the UK could become uninhabitable. Mass relocation would become necessary. Eventually, climate changes would even affect Siberia, which could face a catastrophic flood. Imagine the Gulf Stream stops, the Arctic freezes over, and a giant ice dam forms along the northern coast of Russia. This dam, tens of kilometers high, would block the outflow of Siberia's great rivers, the Yenisei, Lena, and Ob. Unable to reach the ocean, they would flood the surrounding lowlands, merging into a single vast inland sea. Its level could rise by up to 130 meters. While not densely populated, this region is ecologically and economically vital, so the consequences would be immense. This is the most pessimistic climate scenario scientists have proposed. However, not all scientists agree. Some experts believe the Gulf Stream is too powerful a water artery to be stopped by fresh water influx from global warming. They argue that it would take a truly monumental climate catastrophe to reverse it, like the one that happened about 8,200 years ago. Back then, an ice dam from the Laurentide ice sheet, holding back a massive meltwater lake over modern-day Hudson Bay, suddenly collapsed. Over just a couple of decades, all that fresh water flowed into the North Atlantic, disrupting ocean circulation. Even so, it didn't lead to apocalyptic consequences. While the average temperature in the Northern Hemisphere dropped, possibly by 1 to 2 degrees Celsius, and up to 5 degrees Celsius in some areas, Europe didn't turn into an icy desert. So it's not certain that halting one branch of the Gulf Stream would automatically trigger a new ice age. It's a possibility, but not a guarantee. Many scientists believe there's no need to panic. The current slowdown may simply be part of natural cycles. The problem is, we still don't fully understand these cycles. The ocean is vast and incredibly complex, even when we're only studying a single current. None of the experts writing alarming articles about an impending ice age have complete data on the Gulf Stream. In fact, there aren't that many studies on the topic. The most comprehensive research was conducted in the 20th century, mostly by Soviet oceanographers using a whole fleet of research vessels. Today, such long-term expeditions are a luxury most scientists can't afford. Today, long-term research missions aboard specialized vessels are an unaffordable luxury for most oceanographers around the world. On the other hand, they have access to supercomputers capable of creating detailed models of the Gulf Stream's evolution. However, these models still rely on up-to-date data. Most of this data is provided to scientists by Earth remote sensing satellites, automated buoys, and unmanned marine drones. One issue with current models is that they largely ignore deep convection in the Atlantic Ocean, and that might be the key to understanding how the Gulf Stream system will evolve. For example, scientists are now observing new processes driven by warming sea surfaces. When warm water enters northern seas, it cools very quickly, becomes denser, and sinks rapidly. These supercooled waters feed the western deep boundary current, which flows beneath the Gulf Stream. Due to a process called upwelling, cold water from the North Atlantic rises to the surface in the subtropics, which also impacts the climate, the circulation system, and the Gulf Stream itself. But how exactly this works remains to be seen. We know even less about the world's oceans than we do about the space surrounding our planet. This unfortunate situation in modern science needs to be gradually corrected, possibly with the help of advanced technologies like the Quadroon research robot. Quadroin is an autonomous underwater vehicle developed in Germany. It was 3D printed, resembles a penguin in appearance, and swims almost like one. Quadroin can reach a top speed of 15 kilometers per hour and move freely through the water, avoiding obstacles at depths of up to 150 meters. A set of highly sensitive sensors allows the robot to study the characteristics of oceanic eddies. These are small-scale currents that typically last only around 12 hours. However, they have a significant impact on marine life, both animals and plants. Studying them will also help refine our broader understanding of oceanic water circulation. Eddies are best measured simultaneously in multiple locations. That's why scientists plan to deploy 3 artificial penguins at once, which will operate as a swarm thanks to their built-in artificial intelligence. These autonomous devices represent the future of oceanography. If their numbers grow significantly, scientists will finally be able to accurately measure all the key parameters of the Gulf Stream, build mathematical models based on that data, and more or less reliably answer the question, how will this current behave in the future? For now, however, all the talk about the imminent shutdown of the Gulf Stream is little more than reading tea leaves, even if it's supported by scattered scientific data.